Good day, everyone, thank you for joining us today. In this session, we will be presenting an overview of risk-based inspection or RBI, with a focus on the fundamental principles outlined in the API Recommended Practice 580. Our goal is to provide a clear and concise summary that will help you better understand the core concepts and practical applications of RBI in the context of asset integrity and risk management. Before we begin, let's walk you through the agenda for today's presentation. We'll be covering 15 key topics that form the foundation of risk-based inspection, or RBI, as outlined in API Recommended Practice 580. Each section is designed to build your understanding step by step. This presentation agenda are the following: Number 1, key takeaway from the special notes. Number 2, key takeaway from the forward. Number 3, RBI introduction. Number 4, RBI purpose. Number 5, required elements in RBI. Number 6, data requirements. Number 7, damage mechanisms and failure modes. Number 8, POF, probability of failure, analysis. Number 9, COF, consequence of failure, analysis. Number 10, evaluation of risk. Number 11, RBI output requirements. Number 12, RBI reassessment and updating. Number 13, RBI benefits and limitations. Number 14, using RBI as a continuous improvement tool. And, number 15, RBI as an integrated management tool. Let's get into agenda. Number 1 is, key takeaway from special notes. In this section, we'll highlight important disclaimers and clarifications provided in the special notes of API RP 580. These notes set the context for how RBI should be interpreted and applied, especially in terms of scope and limitations. Summary of special notes includes: Number 1 is, general guidance only. API publications offer general advice. Always check local, state, and federal laws for specific situations. Number 2 is, no guarantees. API and its contributors don't guarantee the accuracy or usefulness of the information and aren't responsible for how it's used or any results from its use. Number 3 is, no infringement assurance. Using API publications doesn't guarantee you won't violate someone else's rights. Number 4 is, use at your own risk. Anyone can use API publications, but API isn't liable for any issues or legal conflicts that may arise. Number 5 is, not a replacement for judgment. These documents are meant to share good practices, not replace professional judgment. Number 6 is, manufacturer responsibility. If a manufacturer claims their product meets an API standard, they are fully responsible for ensuring it actually does. And number 7 is, use with caution. Don't rely only on this document, always apply sound business, scientific, and safety judgment. Agenda number 2 is key takeaway from forward. The forward gives us insight into the intent behind API RP 580. It emphasizes the importance of RBI in improving safety, reliability, and cost-effectiveness in inspection planning. Summary of forward: risk-based inspection, or RBI recommended practice. Number 1 is, purpose. API RP 580 document guides how to develop, implement, and maintain a risk-based inspection or RBI program for fixed equipment and piping in the hydrocarbon and chemical industries. Number 2 is, key topics covered, what RBI is, core elements of RBI, and how to implement and sustain an RBI program. Number 3 is, basis. It's built on the experience of professionals in engineering, inspection, and risk analysis. Number 4 is, terminology. Shall is stand for mandatory requirement, and should is stand for recommended but not required. Number 5 is, relation to other standards. API 580 risk-based inspection recommended practice is a supplement of API 510, 570, and 653, allowing flexibility in inspection planning based on RBI results. Number 6 is, assessment focus. RBI must evaluate probability of failure or POF, and consequence of failure or COF. Number 7 is, limitations. API RP 580 is not a rulebook or a set of minimum safety practices. It doesn't replace proven methods or discourage innovation. And it's not a substitute for professional judgment. Number 8 is, legal note. API RP 580 doesn't grant rights to use patented methods or guarantee protection from patent infringement. Number 9 is standardization and feedback, developed under API procedures. Feedback and requests for reproduction should be sent to API's standards department. Number 10 is review cycle. API standards are reviewed at least every 5 years, with possible extensions. Agenda number 3 is risk-based inspection or RBI introduction. Here, we'll define what RBI is and explain how it differs from traditional inspection approaches. RBI focuses on prioritizing inspection efforts based on risk, rather than fixed intervals. Summary of introduction of risk-based inspection or RBI recommended practice. Number 1 is purpose. API RP 580 document sets the minimum requirements and optional guidelines for using risk-based inspection or RBI instead of traditional rule-based inspection methods like fixed intervals. Number 2 is optional use. RBI is not mandatory, it can be used if it fits within the rules of API 510, 570, and 653. Number 3 is inspection planning process, starts with identifying equipment and ends with a detailed inspection plan. Number 4 of RBI introduction is what an RBI plan should include. The first is key risk drivers, the second is inspection methods to be used, the third is scope of inspection or how much and where, the fourth is frequency of inspections, the fifth is other risk-reducing actions. And the sixth is, the remaining risk after mitigation are implemented. Number 5 of RBI introduction is, supporting programs. A good RBI plan should be supported by, the first is, integrity operating windows or IOWs. And the second is, a strong management of change or MOC process. Number 6 of RBI introduction is, terminology. RBI is also known as, risk prioritized inspection, risk-informed inspection, and also known as risk-based inspection planning. Agenda number 4 is risk-based inspection or RBI purpose. The purpose of RBI is to optimize inspection resources by focusing on equipment that poses the highest risk. This helps reduce unplanned failures and improve asset integrity. Summary of purpose, risk-based inspection or RBI recommended practice. Number 1 of RBI purpose is, main goal, to provide the minimum requirements and recommended practices for developing, implementing, and maintaining an RBI program for pressure-containing equipment. Number 2 of RBI purpose is, who it's for, owners, operators, and designers of equipment in industries like refining and petrochemicals. Number 3 of RBI purpose is, what is RBI focuses to, ensures safe and reliable operations by using risk-based inspection planning instead of fixed schedules. Number 4 of RBI purpose is, risk analysis approaches, can range from qualitative or basic to fully quantitative or detailed and data-driven. Number 5 of RBI purpose is, key steps in the RBI process are the following. Number A, understand the equipment design. Number B, plan the RBI assessment. Number C, gather data and information. Number D, identify damage mechanisms and failure modes. Number E, assess probability of failure or POF. Number F, assess consequence of failure or COF. Number G, determine and manage risk. Number H, linkage risk to inspection and process control. Number I, include other risk mitigation actions. Number J, reassess and update regularly. Number K, define roles, responsibilities, and training. And number L, keep proper documentation. Number 6 of RBI purpose is, expected outcomes, includes, number A, a risk ranking of all equipment. Number B, a detailed inspection plan for each item, including, the first is, inspection methods, the second is, scope and timing, the third is, risk reduction achieved, the fourth is, other mitigation actions such as repairs and replacements, the fifth is, expected risk levels after actions. And the sixth is, identification of key risk factors. Agenda number 5 is required elements in risk-based inspection or RBI. We'll go over the essential components that must be included in any RBI program such as risk assessment methodology, documentation, and team competency. Summary of required elements in risk-based inspection or RBI. It is purpose to. The required elements in risk-based inspection outlines the minimum requirements and recommended practices for using RBI to extend inspection intervals beyond traditional rule-based methods. Like half-life intervals. The key requirements for an RBI program, includes, number A, work process requirements. A structured and documented system must be in place to manage the RBI program. It should include, number 1 is, procedures for implementation, maintenance, and reassessment. Number 2 is, roles and responsibilities, including training and experience requirements. Number 3 is, documented assumptions used in the analysis. Number 4 is, timeframe for how long the RBI analysis is valid. Number 5 is, data requirements for the analysis. Number 6 is, risk targets to guide decision-making. Number 7 is, audit requirements to ensure program quality. Number 8 is, scope and boundaries of the RBI program. Number 9 is, triggers for reassessment, such as, process changes, equipment damage or failure, and exceeding integrity operating windows or IOWs. And number 10 is, reassessment schedule. Number 2 of the required elements in risk-based inspection or RBI is data and documentation, includes, the first is, enough data must be collected and stored so that others can repeat it or update the RBI assessment later. The second is, the basis for probability of failure or POF and consequence of failure or COF must be clearly documented. And the third is, all inputs and results used in the risk assessment must be recorded. Agenda number 6 is data requirements. Accurate and comprehensive data is critical for RBI. We'll discuss the types of data needed, including design, operating conditions, inspection history, and failure records. Summary of data requirements in risk-based inspection or RBI. Data validation is required. All data inputs and assumptions used in the RBI analysis must be reviewed and validated by qualified personnel such as process engineers or operators to ensure the operating parameters are accurate and reliable. Agenda number 7 is damage mechanisms and failure modes. Understanding how equipment can fail is key to assessing risk. We'll explore common damage mechanisms and failure modes relevant to different types of assets. Summary of damage mechanisms and failure modes in RBI. Number 1 is, expert involvement. The RBI team shall consult with a qualified corrosion specialist to identify, the first is, damage mechanisms or how equipment can degrade. The second is, optional damage modes or types of damage. The third is, potential failure modes or how equipment might fail. Number 2 of the summary of damage mechanisms and failure modes in RBI is key considerations, includes, number A, equipment design and condition, consider pressure, temperature, materials, and current condition. All data and assumptions must be validated and documented. Number B, process conditions, include all operating scenarios, normal, abnormal, startup, shutdown, idle, and planned changes. Even trace chemicals in ppm can significantly affect damage mechanisms. Number C, fabrication details, review materials and construction methods to list all credible damage mechanisms, including past, present, and potential future damage. Deterioration rates and equipment's tolerance to damage. Number 3 of the summary of damage mechanisms and failure modes in RBI is responsibility. The corrosion specialist is responsible for evaluating the type, relevance, and severity of damage mechanisms based on process conditions, environment, metallurgy, equipment age, and other relevant data. Agenda number 8 is probability of failure or POF analysis. This section covers how we estimate the likelihood of failure, using factors like degradation rates, operating conditions, and historical performance. Summary of probability of failure or POF analysis in risk-based inspection or RBI. The first is, comprehensive damage review. The analysis shall address all credible damage mechanisms that the equipment is or could be exposed to, including cases where multiple mechanisms may apply. The second is material and process evaluation. Each equipment item's materials and process conditions must be reviewed to identify which damage mechanisms are active or possible. And the third is inspection effectiveness. Existing and planned inspection methods must be evaluated to ensure they are capable of detecting the identified damage mechanisms. Agenda number 9 is consequence of failure or COF analysis. We'll look at the impact of failure on safety, environment, and business operations. COF analysis helps us understand the severity of potential failures. Summary of consequence of failure or COF analysis in risk-based inspection or RBI. The purpose of COF analysis. COF calculation steps shall be performed to estimate the consequences that are likely to occur due to a failure mode typically resulting from an identified damage mechanisms. Key factors of COF analysis to consider includes, number 1, flammable events such as fires or explosions, number 2, toxic releases, harmful substances escaping, and number 3, other hazardous fluid releases, spills or leaks of dangerous materials. Agenda number 10 is evaluation of risk. By combining POF and COF, we can evaluate the overall risk. It'll explain how risk matrices and ranking systems are used to prioritize inspection activities. Summary of risk evaluation in risk-based inspection or RBI. Number 1 is how risk is calculated. Risk is determined by combining of probability of failure or POF and consequence of failure or COF. The basic formula is risk equals probability times consequence. Number 2 is what to include. The risk evaluation must also consider the likelihood of loss of containment such as leaks or spills. Agenda number 11 is RBI output requirements. The output of an RBI assessment should be actionable. We'll discuss what deliverables are expected such as inspection plans, risk rankings, and mitigation strategies. Summary of RBI output requirements. Number 1 is risk management focus. Equipment with unacceptable or high risk must be reviewed for possible risk reduction actions, such as inspection plans or other strategies. Number 2 is inspection strategy. The inspection approach must be documented, iterative or regularly updated, and focused on high-risk items. Number 3 is use of inspection results, findings like damage mechanisms, deterioration rates, and equipment tolerance. Agenda number 12 is RBI reassessment and updating. RBI is not a one-time activity. We'll talk about the importance of periodic reassessment and updating the RBI program as new data becomes available. Summary of RBI reassessment and updating. Number 1 is updates are necessary. RBI results must be updated regularly because changes are inevitable. Number 2 is after inspection or risk mitigations are implemented. Once inspections are done, the results should be reviewed to decide if a new RBI assessment is needed. Number 3 is follow codes and regulations. Always check relevant inspection codes like API 510, 570, 653 and local regulations to ensure compliance during reassessment. Agenda number 13 is RBI benefits and limitations. While RBI offers many advantages, it also has limitations. We'll provide a balanced view of what RBI can and cannot achieve, helping you set realistic expectations. Summary of benefits and limitations of risk-based inspection or RBI. Number 1 is benefits. The first benefits is RBI produces equipment-specific plans to manage risk from safety, health, and environmental perspectives, and also economic considerations. The second benefits is plans include cost-effective actions to reduce risk. The third benefits is RBI helps lower overall risk score. Understand and accept current risk. And the fourth benefits is it can identify equipment that doesn't need inspection or mitigation due to low risk, allowing more focused and efficient inspections, less data collection, but with better quality, and cost savings and improved safety. Number 2 is RBI limitations. RBI cannot make up for missing or incorrect data, poor design or faulty installation, operating outside safe limits or integrity operating windows, failure to follow through on plans, lack of qualified personnel or teamwork, and poor engineering or operational judgment. Agenda number 14 is using RBI as a continuous improvement tool. RBI should evolve with your organization. We'll show how it can be used to drive continuous improvement in inspection strategies and asset management. Summary of RBI as a continuous improvement tool. Number 1 is ongoing improvement. RBI helps continuously improve inspection practices and reduce the risk of equipment failure over time. Number 2 is reassessment triggers. RBI should be updated when new inspection data becomes available, there are changes in operating conditions, and new industry experience is gained. Number 3 is adjust risk management plans or RMPs. Update RMPs as needed based on new insights or changes. Number 4 is reassessment triggers. RBI can help identify limitations in current inspection technologies. If inspection tools aren't effective or cost-efficient, other risk mitigation methods should be used. Agenda number 15 is RBI as an integrated management tool. Finally, we'll discuss how RBI can be integrated with other systems like reliability engineering, maintenance planning, and safety management for a holistic approach. Summary of RBI as an integrated management tool. Number is, fills a gap. RBI addresses risk areas not fully covered by other tools like Process Hazard Analyses or PHA, Integrity Operating Windows or IOWs, and Reliability-Centered Maintenance or RCM. Number 2 is, supports planning. RBI helps create inspection and maintenance plans that support safe and reliable operations. It also helps with budgeting and staffing by identifying what's needed to manage equipment risk. Number 3 is, integration is key. RBI should be integrated with Integrity Operating Windows or IOWs management systems and a strong management of change or MOC process. This helps control and manage damage mechanisms in fixed equipment. Thank you.